How you doing?
What is I saw you just messaged me a bunch of stuff, didn't you?
Yeah. Can you check that? Tell me if it's good to be posted, and then after, like, right before office hours end, can you post it if it is good enough?
Let me see. I mean, you can post it. You should have permissions, right?
Oh yeah, but I can't publish the channel. Oh wait, the channel published. Oh, channel is published already. You think
Okay,
that's good?
nice. Yeah, it looks good.
Alright. Should I
Yeah,
just
I like
publish
that.
it now then?
Yeah, and then yeah, I like the point system. Yeah, make sure you put the point system in the and stuff in it too. You know.
I'm just gonna copy the message I sent you and just kind of post that in.
Okay. Here, let me edit this. Let me edit this category so that people can see it though.
Oh, where's the reaction rule that you set up?
Yes, I'll do that too. One sec. Everyone can view the channels. All right, I just set that up.
We set dailies to only be limited to that, right?
Correct. It's yeah. I think it's only in the in the sorry. I think it's only in the common channel.
Yeah,
Well,
you
it's
need to
in
set up the permissions for that.
GG common channel. Here, I want everyone that can view this, but not everyone can send messages in it though.
Hello.
Yeah, what's up? Send messages is no. There we go. Okay, I want to change that, and then here common area. Let me change that. One sec.
He's changing common area.
No, that's okay. Yeah, everyone can
Oh,
view
actually,
it.
I'm gonna ping students real quick for this when I do it.
Yeah, go for it.
So now,
What's up, Penn Center? What's up, Noise? Ping the students after maybe after the stream, because I already pinged them right now for the stream. Let's just like
I'll do it after office hours then.
perfect. Yes, dope. Yeah, and then I'll create a reaction roll so that so that people can join. Yeah, maybe put something in the news there about how they need to. Well, whatever. We'll put it in the reaction roll, I guess.
I already have in final remarks that said you need to kill the game with reaction roll.
Pardon?
I have it in the final remark thing for that, but we don't have the reaction roll set up.
Yes, yeah. Let me after office hours. Let's just meet. I'll set up the reaction roll. You can ping all the students, and we'll do it. Cool.
Okay.
Sweet. Okay. Awesome. Goldie Woldy, are you sick? I don't know if I'm
I'm
sick.
up for a bit.
Okay, you're chill. I don't know if I'm sick. I do definitely have a cough. I don't know. I keep like not being kind to myself over the weekend. I don't know. Waluigi. Looks like you had an interesting weekend. I did. Yes, no, very much. But that's why I'm coughing, because I didn't really sleep very much. Wasn't the healthiest of weekends. I dropped an absolute game at work on Sunday, but then realized it probably wasn't such a good idea. What's dropping an absolute game? What is that? Tell us that. What is that? Too much smoking? No, I don't really smoke. Well, I did smoke a couple cigarettes, but like, don't do those. Those are bad for you. Dropping absolute game is like Riz. Oh, like spitting game. Okay. All right, that's cool, man. Were you doing it to Ashley? Like, who is it? Cigarettes are real fun. I kind of do agree with that. I mean, they're all terrible, but yeah, I kind of do see like the people like. Isn't that what your dad said, Noise? That like, can you stop smoking these candy flavored peach cinnamon? Like, I love when people are, oh, I'm gonna go smoke. I'm like, do what? Like, what are these? What are you guys doing? Yeah, just go smoke cigarettes like a real person or something. But also don't do that because cigarettes are bad for you. I don't know. It's weird. Everything's weird, dude. The whole world is weird, dude. This whole Israel thing's weird, dude. Like, I don't know what's going on anymore. I'm just trying to teach math and science, and I keep just not believing what's going on in the world. I'm just like, what's going on? Was at the till and asked for her ID. Oh yeah. Oh, your friend told me about this actually, and she giggled. She giggled or something. He said, but that's because she's much older than you. Yeah, no, that's called giving girls mixed signals, Noise. It's what girls do to guys all the time. Don't do it to girls unless like you want to reap the consequences of that. Anyways, such as, yeah. Bum, 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 bum. Out of pocket millennials. This was kind of a funny thing that came up. Came up on my news. I thought it was kind of funny. It says Gen Z workers are roasting their millennial colleagues for using the phrase "out of pocket" because it has a different meaning for younger people. And it says, like, Gen Z TikTokers are poking fun at each other who use the term out of pocket. Millennials and boomers use the phrase to say they'll be away for part of the day. No, I've never used the word out of pocket to say I'll be away for part of the day. And they say, but for Gen Z, it means acting chaotic or in an out of control way. Yes, I agree with this. Whenever I say something's out of pocket or someone's acting out of pocket, that's what I mean. And I belong to this millennial generation, so I don't know. I thought it was kind of funny. Have you ever been out of pocket while at work? Have you ever been out of pocket while at work? Yeah, I don't know. That's just too funny. Generational misunderstandings. Out of pocket means you pay for it out of pocket. Yeah, paying for something out of pocket is definitely, yeah, that's a thing for sure. I know about that. But like, if you say someone's acting out of pocket, it usually means they're acting crazy. That's what I've always known it to be. But I guess it also means you can be out for the day at work. Who knows? People got some weird opinions on things, man. Yeah. Although I have, I've been really liking. We're getting a lot of people in the Discord now. Like, I see a lot of people joining, and then I see a lot of comments on YouTube and stuff. What's up, Ethan? What's up?
So, I just heard what you said about a lot of people. How can none of them are just players?
Oh, some of them are chess players? Oh, you're telling people about the Discord because of chess?
No. But see, I'm seeing that it's like there's a lot of people joining apparently, but none of them are chess players.
Oh, are they not chess players? I mean, check if they got the rules, if they got the roles. But I don't know. This has been really nice. So, like, my YouTube has been kind of blowing up. I guess everyone's taking exams right now or something because this girl was like, "Yo, saved my life. I have a midterm. I could not understand this stuff." I was like, "Yeah, it's implicit differentiation." This person was like, "I don't know. I've got one of the most important exams of my life. Thanks for the help." I'm like, "Cool." Or like, "Wow, you summarized everything my teacher said for the last 2 hours." Yeah, I don't know. It's kind of cool. That makes me feel better about the world. I am not sharing my screen. You're so right. Thank you. Thank you for telling me that. I should be doing that. Kiss Killer, thank you. I forget sometimes. My head's still kind of fuzzy from the weekend. What's up, Ethan?
I feel like I should. I don't know if you will call me crazy, but I feel like I will want to start a no chess account.
You want to start another chess account?
Yeah, I'm just.
Oh, dude, why? Fuck you, Discord. Why did Discord just crash? Excuse me? Oh man, I can't stand this, dude. What? Discord just decides to crash now? Why can't anyone like create something that like doesn't fucking fuck? Oh my god. Sorry. All right, let me go speak on the stage again. Let me share my screen. Sorry, Ethan, my Discord crashed for some reason. I don't know why it crashed, but it did. Enable enable clipping. There we go.
Okay.
Right?
Like that.
Damn technology.
At the very wrong time.
I know it did. Yeah. Like, why do I have to become speaker again? What? Fix your shit. Discord. I had the same thing happen to me. What was it? I was playing Call of Duty with my friends the other day or something, and like, look at this, dude. I'm right about to like line up a really nasty headshot on this guy, right? And then it's just like, nope. Call of Duty has decided to stop working. Yeah, I was like, man, it wasn't very cool. What's up?
Like I was saying.
What's up?
I feel like I should start a new chess account channel.
Why should you start a new chess account? You have like an 1800 ELO.
Yeah,
Or
but then
1900 ELO. Why? You No, this is chess is not like Call of Duty where you just like reset your account to like do like a prestige tier or something. Like you want to keep getting better.
Oh, okay.
Yeah, don't do that. You worked very hard for your rating. Don't reset it. Because yeah, you would go to here's what happened, Ethan. You would go to like playing easy people again, but it would just be easy. You wouldn't learn anything from it.
Mhm.
Reject Bill Gates, dude. Yeah, reject the vaccine, dude.
Yeah, also, speaking of the rating,
Yes.
Pickle,
What? What's Ethan? What?
you remember what you just said about rating?
Yes. ELO rating. Yes.
Guess what? Guess it.
What's up?
Oh, don't you want to take a guess on what I would
Did you
wanna
hit
say?
2,000? Did you hit 2,000?
What do you think?
I think you did. Show me a screenshot. I told you to show me a screenshot. I'll give you a prize for it. I'll give you 5 bond coins, right? Is that what I said? I said I'll give you 5 bond coins if you hit a 2,000 ELO. ELO, by the way, for those that
Also-
don't know, is a chess rating. It's like how good you are at chess. You guys have like diamond ranking, gold ranking, plank, Onyx. I don't know. They have all these things in like Fortnite, Halo, and whatnot. In chess, they've always had a rating system. It's called ELO, and some of like the best people in chess have above like a 2,000. I think Electric Light Orchestra, maybe it is. I don't know what ELO stands for, but when I played chess, mine was I think around a 1,200 or 1,300, and Ethan is like well into the almost 2,000s, I guess.
Almost, yeah. I'm not officially at 2000, even though it does say I hit 2000. It's not actually that true, okay? Because it's like
Okay.
I could immediately lose to someone else. That's how it
Okay.
is.
No, but if you make it, you make it, dude. That's dope.
Mhm.
Okay. Cool, dude. Yeah, show me a screenshot. I'll give you points for it.
Also, speaking of those points, why did you actually give me 2 points for beating the hardest spot on chess?
I don't know. I thought it was cool. I just thought it was cool. I give bond coins out to people just randomly. If if I think something looks cool, like you did something cool, I'll give you bond coins for it. You know?
Alright.
Yeah. Okay, cool. All right, let's start off the stream. We got some good questions. All right. Welcome everyone to Office Hours. My name is Dr. Gold. It's Actual Education. Stream helps you out with math homework, science homework. Today's stream was a good one. I tried connecting to Discord. Gold has inspired me to be better. Have I inspired you to be better? What? Oh man. I'm just trying to get people to look at me the same way like, a dog looks at its owner or something, just being like just no judgment, just be like, you're the best person in the world. And I'm just like that's the person I aspire to be at some point. This is a good question though. from you Noise, right? We're doing probability here. In a game, a red dice and a blue dice are thrown. Well, first of all, the dice are different colors. That's very interesting. What's her PSL? What? Or what does PSL stand for, Penn Center? Do I even want to know? I don't know if I want to know. Pumpkin Spice Latte. Oh, wow. They even have an acronym for it now? Damn. A white girl looks at her Pumpkin Spice Latte. It's gotten too far, dude. Alright. In a game, a red dice and a blue dice are both thrown alternately, starting with the blue one. You win when you have scored a 6 on the blue dice twice. However, if at any point the red dice shows a 1, the game is over and you lost. Oh no. This kind of reminds me of like craps. I love craps. Craps is like one of my favorite games. Okay. I don't think it's pretentious coffee Noise because it's the most basic shit ever, dude. Like, it's not like you're not being elite by getting a pumpkin spice latte. Like, no. If you said something like, "Oh, I have a cortado with I don't know, organic oat milk something," that's being pretentious, Or these people that demand that their coffee be a pour over at a certain temperature for a certain amount of time. That's being pretentious with coffee. His maple hazel latte. Wow. Yeah, that's not good. Okay. All right. Find the probability that you win on the 10th throw of the blue dice. Is this for your class Noise? This is super advanced already. Okay, so you end up throwing a red dice, and then you throw a blue dice, right? And then you kind of alternate with this. Oh, wait, no, we start with the blue one, though. My bad. We gotta start with the blue one. Okay. You win when you have scored a 6 on the blue dice twice. I don't think you have to do it consecutively, though, right? However, if at any point the red dice shows a 1, the game is over and you lost. Okay, this is kind of cool. Okay. So, let's see the 10th throw, right? So, this would be 4 throws, right? One, 2, 3, 6. Probably need a couple more. 8, 10. Okay, there we go. Red, blue, red, blue, red, blue, red, blue. It's kind of fun. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's how the game's gonna go. We're gonna throw a blue dice and a red dice 10 times. This is actually a question we realized. That's pretty cool. Okay. We want to find the probability that you win on the 10th. So here's a good question. Is it you have to win just on the 10th, or you have to win by the 10th? Let's say it's just winning on the 10th. Say, like, you have to win on the 10th, right? So I know, for instance, on the 10th roll of... Oh, wait, the 10th throw of the blue dice. Oh, man. Oh, wait, so actually there's 20 throws then. Right? Because I throw the blue and then throw the red. Okay. Because this counts as, like, for instance, like the first throw. Okay. So we need to come up with, like, kind of an equation here. You're missing white in between red and blue. Yeah, where's my freedoms for cheeseburger? Okay. Okay, so whatever. This is going to keep happening until ... we get to the 10th throw. Okay. If at any point the red dice... So I assume once I win here, I don't need to throw the red dice again. So I assume that, like, we don't need to deal with this. Okay. So I know I need to roll a 6 on the 10th row. Okay. That has to happen in order for me to win, right? So that's a 1 out of 6 chance. Okay. And then sometime in the 9 throws beforehand, I needed to get a 6 as well. But I needed to only get it once. Because if I got it more than once, then I wouldn't have won on the 10th throw. I would have won beforehand, right? So that's a 1 out of 6 chance, right? And then this is like an end choose thing, right? So this is just 1 out of 6, and then this is, what is this, 10 choose 1? Is that how this works? I'm trying to think how this works, sorry. Yeah, it's a 1 out of 6. And then there are 9 different ways I could have done that, right? But then the other ones have to be... I have to not hit it. Oh, I think it's this. Okay, wait. I think it's 1, 6. This is the binomial thing, isn't it? And then it's 5, 6 to the 9ths, right? Yeah. Yeah, this is... Okay, this is binomial. This is what this is. Okay, what is this? Binomial probability. It's pretty cool. Wow, this has a lot of stuff on it, but yeah, here we go. Did we try to call them freedom fries? Well, because we didn't want to call them French fries? It's kind of rude. Okay, well, that is not the image I want. Where is it? Come here. Copy image. Yeah, this is what we're going to use, Noise. This is a pretty cool thing. Yeah. So binomial is... So the reason they call it binomial is because you either have a success or you have a failure. So bi means 2, right? So there's only 2 choices. You either win or you don't. In this case... We're going to call winning on the blue dice, right? Rolling a 6 and losing you know, or not winning, I guess, anything else. So we're gonna use this formula, where this is called n choose x is what they call this. And right, so the probability of winning, success in one trial is going to be 1/6, and the probability of not having success is 5/6. And I want there to be exactly just one success in the first 9 trials, and everything else has to be a failure. Okay, so this is going to be 9 choose 1, right? Which is actually not too hard, right? Because that's 9 factorial over 8 factorial times 1 factorial. So this is just 9. Okay. So I need 9 times 1/6 times 5/6, right? That's a probability for me to get only 1/6 out of the first 9 trials, right? And then additionally, I need to get another just 1/6 on this one. So then we're also going to multiply that by the probability of getting a single 6 on the 10th throw. Okay. That's what that is. But then we also need to make sure that we don't like screw up with the red stuff, right? So I believe, and right, it's anytime I throw a red shows a 1, the game is over and you've lost. So I think we also need to we need to multiply this by the probability of not getting a 1 on any of the other 9 trials. So that's going to be times 5/6 to the 9th, right? Because then that's all these 9 tries when I'm throwing the red. So I believe this is the answer. So what does this come out to be? This is 9 times 1/6 squared times 5/6 to the 10th. Let's see. See what that is. Do you have the answers for these, Noise? Or this is homework you had to do? Calculator. Okay. We have 1/6. Good. Squared. Times 9. Okay. And then times 5/6, which is basically just going to be 1. So I think it's just a quarter. Oh, wait. No, I'm wrong. Sorry. That's going to be actually, wait. Times 5/6 to the 10th. Okay, cool. So that says there's a 4% chance. I think. You have answers? Okay, is that correct? That if you win on the 10th throw, it's like a 4% chance? I think I did this right. I'm curious. Okay, let's try this one as well. Sorry. Find the probability that you lose by the 3rd throw of the red dice. Okay. Okay, well, the only way to lose is to... You have to roll a 1 on one of these, right? So... And then you also have to not win, though, right? Well, okay, I guess not winning doesn't make it. Well, so, okay, yeah, because they say it's 0.0113. Am I wrong with this? I feel like I'm right. Wait, let's see this. Find the probability that you win on the 10th throw of the blue dice. I think it's 9 choose 1. Probability of success. Probability of failure. Cool. 9 choose 1 is just 9. And then you have to roll a 6 on the last one. That's the 1/6. And then you also had to not roll a 1 on any of the red dice. I wonder if they wanted this. Oh wait, this should have been. Yeah, I wonder if they wanted this to the 11th. Sick. No, that just drops it down to 3%. Okay. Let me see if the internet... Do you have the solutions for it? Can I see how they did it? Actually, I probably have it. One second. I'll probably find it here and check real quick. It's in the vectors thread? Okay, let me check it. Thank you. Let's see what they did. Nope. No, not that one. For the blue dice, okay, let's see. Okay, 9 choose 1. See, I was correct with this, right? To win on the 10th turn, the blue dice must score 6 for the second time on the 10th row. I agree with this. Yes, okay, so we had all this. Yeah, we had this. Oh, thanks, Sam. Appreciate that. Yeah, what did I do wrong here? I'm pretty sure I'm right. And wait, and 9 choose 1 is just 9. Okay, wait. Yeah, no. Oh, noise. Sorry. Yeah. No. I just typed this in wrong. 9 and 9 is not 10. 9 and 9 is 18. Yeah, I was right, dude. Okay, I'm just... Brain is fucking mush today, dude. God damn it. Yeah, I was right. I just dumb algebra mistakes. Yeah, it was this, and then it was this to the 18th. But still different than what they get. One sec. Wait, 9 choose 1 is just 9. 9 times 1/6 to the second. Oh, and they have it to the 17th, not to the 18th. Okay, well, let's see why that is. Oh, interesting. Yeah, 9 choose that. 1/6 to the second. 5/6. Oh, to the 8th. Yeah. Yep. Yes. Okay. Okay. Yeah. Okay. I was just all off by 1 on these. Yeah. Whatever. This is like 3%. Yeah. Cool. Yeah. Thanks. Yes. Okay. Cool. All right. All right. We're at least we're thinking correctly. This is cool. Okay. Here. Let's just do this. All right. Did that make sense though, Noise? That makes sense how we did that one? Jamarcus probably a little confused, right? Have you seen binomial distributions before, Jamarcus? Have you seen this stuff? Class again today. Yay. This stuff is very useful. That's what we're using for a lot of this. Okay. Find the probability you lose by the 3rd throw of the red dice. Okay. So I just need a 1 out of 6 out of any of those times, right? To lose. So again, that's you know the ends, but you don't know the rest. Yeah, okay. Binomial distribution just says so if you have 2 events that can happen, which is like a success and a failure, and you want to know out of how many trials exactly a certain number of successes happen, you use this formula. Which this right here, this is n choose x is what this is. And then this is the probability of success, is the probability of failure. So in this case of losing by the 3rd throw means I need to have, let me think here. Interesting. Okay, but losing by the 3rd throw. So on the 1st throw, I can roll whatever on the blue. I don't care. Yeah, and this is where I can't say it's the probability of not losing. Is it? Well, maybe I can. 1 minus the probability of not losing. I think I can do that. Because otherwise I have to do the probability you lose on the 1st throw, plus the probability you lose on the 2nd throw, plus the probability you lose on the 3rd throw. Because that's losing by the 3rd throw. The probability of losing on the 1st throw is 1 out of 6, right? Because that's just when you roll the red. The probability of losing on the 2nd throw is going to be 1 out of 6 again. Well, okay. Well, it means you want to have not lost on the 1st throw, which means for the red. So this is the 2 dice makes this complicated. Okay, here. All right. You can do whatever on the 1st throw. It doesn't matter. If you roll a 1 on the 1st throw, you're done. Okay. All right. This is what we're gonna call like 1st throw. First throw losing. Okay. Let's see losing on the 2nd throw. Okay. Losing on the 2nd throw means you need to not lose from the red dice on the 1st throw, and then you need to lose from the red dice on the 2nd throw. So that's this. Okay. But also you need to make sure you didn't win already, right? Because if you rolled a 6 and then another 6 from the blue dice, you would have won, and then you wouldn't have thrown a red dice. So this needs to also be multiplied by making sure that you don't roll 2 6s, which is 1 minus 1 over 6 squared. Right? Because this would be rolling a 6 and a 6. And you need to make... You're only going to be able to lose if you haven't won. Because if you win on the second throw of the blue dice before you can even throw the red one, you can't lose. Yeah, this is tricky. Okay. Okay. And then... Okay, so then let's see. So that was the 1st throw losing. This is the 2nd throw losing. And then here's going to be the 3rd throw. So on the 3rd throw, you need to have, again, not lost from the red dice on the first 2. Yeah, I ain't doing all that. There probably is okay, again, I'm kind of doing a brute force method here to do this. I think I can do what's called like the negative space of this, where I could do 1 minus the probability of winning. And that's the probability of losing. I'll show it. Probably would be the same. Okay. So this would need to happen, okay? And then we need to make sure we haven't won already, right? And that's where actually you need this. So that's going to be 1 minus, and then it's going to be 3 choose 2, right? And then that's going to be 1/6 squared, 5/6 to the first. And this is not winning with the blue. This is a very cool question. I actually really like this. Noise. These are cool. Yeah. And then 3 choose so yeah, what is just I'm just gonna get 3 choose. I'm just too lazy. 3 choose 2 is 3. Okay, awesome, cool. Alright. So this is the same thing as 3. Alright, so let's pull up the calculator and see if this all works. I'm curious. So I have here, and I'm gonna make things easy. So on the calculator, if you don't want to like keep typing in things and whatnot, you can assign them to variables. I'm gonna call 1/6. I'm gonna call that A. I'm gonna call that winning, or whatever. I'm just gonna say it's the low one, and then I'm gonna say that 5/6 is implied to B. Okay. So now I know it's 1/6, which is A, plus this is going to be B times A times, and then it's 1 minus A squared. And then we got to add that to B squared times A times, and then this is going to be 1 minus 3 A to the second B. I hope this is a nice answer. What do we get? Oh, okay, 41%. 41% chance. Is that the correct is that the correct answer? Let's see if my math is right today on the second time's a charm. Yeah, it was helpful. Thank you, Nonsense. I appreciate that. Pretty much, yeah? Awesome. That's so cool. I like that question. Is there a simpler way to do it, though? Is that how they do it in your solutions? Noise? Is that how they do it? I feel like anything in probability and stats, there's always like a easier way to do things. Yeah, we can do these. Let me do some other people's questions real fast, but then like these are also pretty cool. This where it says find the probability that the game lasts more than 12 throws of more than 12. You have to do 1 minus the probability that, you know, you win in under 12. That's kind of the strat for that one. Pretty much, they use negative binomial distribution and geometric distribution. Okay. Find the probability that the game ends on the 6th throw of one of the dice. Okay. So this is the probability of winning in 6 plus the probability of losing in 6. I can't do either. You can't do this? That's pretty easy. Do you not understand the binomial distribution? What is the geometric distribution, by the way? Sorry, what is that? The probability that the first occurrence of success requires k independent trials, each with success at probability p. Okay. It's kind of like the inverse, I guess, of the binomial. Because this is the probability that it requires a certain number of trials in order to get a single success, versus the binomial distribution is what is the probability of exactly getting so many successes within so many trials. Yeah, they're all cool. Just, you hate maths? 0 to 10? No, dude. Noise, you're so good at math. Chill. Send me the solutions of those when you get a chance, though. I'm curious. I would like to see those. I want to see if they did it, how they did it. I mean, this way, again, it gets you the right answer. It's not very elegant. And if we started going to like 4th or 5th throw, like, I guess we're starting to see a pattern, but it gets messy. And a lot of times in statistics and probability, there's a prettier way to do this. If you just want to get the right answer, then, like, you know, this works, I guess. But it's cool. Let's see. Ooh. Okay. Teacup, what's up? You here, Teacup? Hello? Okay. According to Stephen's law? Who's this dude, Stephen? What's up, Stephen? Stephen's law in psychology. The perceived magnitude of a stimulus is proportional to a power of the actual intensity of the stimulus. Okay. I almost burnt my house down. Yikes, I forgot a pumpkin in the oven due to my excitement with probability. I think probability is really fun. Yeah, right, Penn Center? I mean, not so fun that I'd want to burn my house down. Were you cooking the pumpkin for the pumpkin spice latte that you're going to make? I bet he was. Okay. Okay, this is cool. The perceived brightness of a light satisfies this. B's equal to k I to the 2/3, where I is light intensity, and whereas the perceived heaviness of a weight satisfies this. Oh, okay. They're two different things. This is kind of cool. Okay.
Hello.
Contrary to popular belief, I'm not a basic white girl. Dude, who the fuck is Steven? Yeah, who is he's some psychologist, I guess. I liked your stream, Penn Center. I was checking yours out. You got more of the. I gotta take some time and just work on my Twitch, getting more of the fancy stuff in there. Fuck Steven, I'll kiss his dad. Okay. Alright, Teacup, how do we do this one? It says calculate dB, DI, and DH, DW. That's cool.
Let me see this. On stream. Oh, wait.
Let's get dB, DI.
BDI. Okay, so we want to do the derivative of B
B, with respect to what?
with respect to I.
Nice. Yes, respect to I.
So
Good.
we have -2 over 3.
No,
Then
not negative.
times 2 over 3.
Where are you getting the negative 2 over 3?
Because they gotta subtract it by 1.
Well, first we want to multiply this thing out front. That's what we want to do.
I do it. I lower. I change the exponent. Then I multiply.
Okay. Well, no. Yeah, but you don't want to multiply by the changed exponent. You want to. Oh, okay. Yeah, no, this isn't related rates. Not yet. This isn't related rates yet, but yeah, it's getting there. Okay, so what is this? What does this become?
Okay, so we have k times 2 over 3.
Good.
I negative 2 over 3.
No.
Wait, I times negative 2 over 3.
No. I got to drop this by 1. What happens when I drop 2/3 by 1?
Negative 2.33333.
What's 2/3 minus 1? 2/3 minus 1 is 2/3 minus 3 over 3. What?
Is it negative 1/3?
Negative 1/3. Yeah, you're good, Jamarcus. Yeah, you don't need the product rule here because k is a constant. You see how they say k is a constant? That means you don't need to like worry about it when doing derivative things.
K is
all good.
never changing.
Good. Okay. All right. Let's get what dHDI is.
Oh, so we need we are doing the derivative of h with respect to I. Wait a minute, there's no I there.
Oh, sorry, dW. My bad.
Okay, so we have 3/2 minus 1, which is just 1/2. And then we times it all by 3/2. Well,
Good.
we times k by 3/2.
Yeah, cool. So you get if we want to make this like look kind of nice, we get that this is 2/3 k, and then do you remember how to write this as something that's not like a negative exponent?
You put it in the numerator or the denominator or the denominator.
Denominator, right? And then what does this become? 1 over what?
1 over 1 times 3, 1 plus 3, 1 divided by 3.
Yeah.
Something sign.
It's technically I.
Negative 1 plus.
It's technically I to the 1/3, but I to the 1/3 is the same thing as the cubed root of I.
I'm not smart. Okay.
It's okay. And then this is 3/2 k, and then what's this going to become?
W, no, it'll be, well, it's not even negative, so it'll just be W times 0.5.
No, W to the 0.5, right? But what do we talk about things to fractional exponents?
Fractional exponents. Well, we can't put the W in the denominator because it's not
No.
negative.
No.
We
So let's remember,
probably-
like square root of 3. This is the same thing as 3 to the 1/2. Right?
Yes.
4th root of x to the 6th. This is the same thing as x to the 6 over 4. So the same thing, it really is x to the 3/2. So anytime you have a fraction as your exponent, this top one is whatever power it's raised to, right? And then this bottom one is whatever the root is.
Oh.
Square roots this is the same thing as this technically, but we just leave it. So what is w to the 1/2? Noise. Oh fuck. Uh-oh. What happened, Noise?
I'll be right back.
You have a physics test tomorrow. Oh, Noise. Why don't you ask some physics questions so I can help you in physics? you want it?
And I'm back once again.
Okay. W to the 1/2 is the same thing as the square root of w.
Yeah, because it's W to the 2nd power and it's getting divided. Wait, no. It is W to the 1st power and it's getting squared. Square rooted.
Square rooted.
Probably.
Yeah, Noise. I hate thermodynamics, but I can still help you with it. It's okay. Okay, so then they say here, explain the following statements. A 1 unit increase in the light intensity is felt more strongly when I is small than when I is large. That's cool. So B is like the perceived brightness is what they're saying, okay? So let's maybe like go a little bit further. Okay, do you remember like dy dx, right? When I have a linear equation, let's say I have y is equal to, right, mx plus b. What's
Yeah.
what is dy dx in this case?
dy dx? Okay, well, it is dy is b and dx x.
Okay. Dy dx means take the derivative of y, which is this thing, with respect to x. Which means x is the only variable I really care about when I'm doing derivatives. Okay? What's the derivative of this with respect to x?
Okay, well, let's see. We got x to the 1st. No, is that x to the 1st or x to the 0?
It's x to the 1st. If it was x to the 0, this is, for instance, x to the 0, because x to the 0
Okay,
is just 1.
Now we got x to the 0, and then we times everything by 1. So it's just m x to the 0 plus b.
Good. X to the 0 is the same thing as 1. But wait, B doesn't have an X on it. What's the derivative of B? If it's just a number. What is it?
Is it constant?
Yeah, what's the derivative of a constant?
The 1.
No.
Is it 0?
0. Like you said here, Teacup, dude. This is the same thing as X to the 0. So I just pull the 0 out front, multiply it through, then it's just 0. Right?
Wow. Makes sense now.
Okay. So what we showed here is that, okay, for a line, right, which is like y equals mx plus b, right? dy dx is equal to m. What is m?
M is the slope.
Slope. Good.
Wait, yeah.
Do you remember, like, from very, very basic stuff, right? When we were doing, for instance, the equation of a line. What was it? You know. You had, like, the change in y and the change in x, okay? No, don't do point slope.
Yeah, point to form. Let's go.
Okay, right? Slope, right, is change in y over change in x, right?
Yes.
Okay. Let's say that this is like dollars and then this is like hours worked, okay? If I say my slope is equal to, let's say, 25, right? What does that kind of tell you about like the money situation here? If the slope here is 25.
So if he's working for like 25 hours and he makes more money, obviously.
If he works more time, he makes more money, right? The slope is kind of like a rate of change. What's up, Learning Laser? I use Group World.
Use this Group World.
Yeah, I like Group World. They're cool.
Group World.
So slope is like a rate of change, okay? And what you guys learn here, right, when we do delta y over delta x, right? Let's say, again, this is equal to 25, which is the same thing as 25 over 1. That means for every 1 unit increase in the amount of time I work, every change in x, right, hours, if that's 1, okay, my y, the amount of money I make, changes by 25, okay?
Wow, he's making a lot of money per hour.
25 is decent, I guess. I mean, I wouldn't work for 25.
25 is like 10 higher than the minimum wage.
Well, it shouldn't be. Minimum wage should be like $20, honestly.
Minimum wage is like 14.
I know. Yeah, no, it's really low. And, you know, people will argue that, oh, minimum wage is minimum wage. Like, it's not meant to be like an actual living wage. I'm like, okay, well then why is
9
it?
to 5 is like an 8-hour shift. So then we do it 8 times 25, assuming you don't go on break. That's $200 for one
Mhm.
work day. You work for, let's say, 5 days a week, so we do 200 times 5.
Yeah, so it's what? It's a grand. It's a grand a week.
That's like $1,000 a week.
Yeah, it's 52K.
Then you have 2 days off, so that's like average.
It's pretty average. Yeah, 52K. Yeah, isn't bad. You can live off 52K. You can't live off 52K in Los Angeles. Like, not very well, at least.
You can come off anywhere else.
Again, it depends. It depends where you live. Yeah, for sure. Yeah, cool, Learning Laser. Yeah.
Anyway.
That's. Okay. Hey, what I'm getting at
You
here.
live in Texas, though. You can get a American.
Yeah, and if you lived in Montana, you know, 50K will get you a lot further too. Okay, what I was trying to get here though is, right, okay, dy dx, this is similar to like a slope, and this is what's technically called like an instantaneous rate of change, is what we say, okay?
Instant change. Let's go.
So when we look at dB di, okay, what does that tell you about the change in this versus the change in this? First of all, what was B? What was B from this whole thing?
B was ki 2/3.
No, but what was it like in the word problem? What did they call B?
Right.
Perceived brightness. It's like how bright you think something is. Whereas I
that 1 lumens is the actual how.
is actually how bright it is. They call it intensity, right? Okay. So here's what we're seeing is that dB di. So this is, for instance, for every 1 unit change in the actual intensity, this is how much the perceived intensity changes.
Yes.
Okay? In the same way here, right? For every 1 hour that I worked, this was the amount of more money that changed, you know, 25. Daily reminder Suvat. There's no Suvat in here yet. Okay. And they're saying it's equal to this, okay? And you see how here in this question they say a 1 unit increase in the light intensity, right? That's this. Is felt more strongly. So they're saying that the perceived brightness is stronger when I is small rather than when I is large. Let's try to understand why that is. Because they
Okay,
want you to
if I
think.
is the sun, they're gonna think it's the sun. But if I is like all people that
No, but you can see it in the math here. You can see it in the math. We're going to show you how it is in the math, okay? Let's first, okay, where is I in this equation? Where is it?
I is the cube root in the denominator.
It's down here. Good. Good. Okay. And do you see how, okay, this is in the bottom, right? Okay. So if this is a big number, what happens to the whole thing? What happens if I divide by a big number?
If you divide by a big number,
Yeah.
okay, well, with everything else gets. I really wanted to say smaller, but it's not. Small.
It does. Yeah, things get smaller. Yeah. If I divide by a big number, I get a small number, right? You know, 1 over like 69,420, dude, this is like really tiny, right?
Yeah, like 0.00725.
Yeah. So the important thing here, teacup, is that if this number is small, this whole thing will be big. Okay?
Yes.
So,
Hey, look, it's in the word problem.
yes, if I is small, right, then dBdi, which is this whole thing, will be big. Okay? And dBdi, if it's a big number, says that for every 1 unit increase in what the actual intensity is, my change in the perceived brightness will also be very big. So that's what they're saying here. It's felt more strongly. It means that if on the light bulb, if I change it from, I don't know, like 1 watt to 2 watts or whatnot, my eye will perceive that change to be more than 1 watt if the intensity is a lower number versus it being a bigger number. It's kind of cool. It's, again, because this is a physical concept which is being explained by a mathematical equation and numbers. All right. So the other one they have here is, okay, so adding another pound to a load is felt more strongly when W is large than when W is small, okay? So let's remember, H is the perceived weight of something. It's how heavy you think something is compared to how heavy it actually is, which is W, okay? So dHdW, whatever that number is, that tells you for every 1 pound increase in the actual weight, this is how many pounds I feel like it weighs. Like the perceived heaviness is what they're saying. Because again, this is a slope. It's just a slope. So in this case, if W is big, what happens to this?
W is big, it will get small.
No. If this is on top, right?
Okay. Yes, I mean, are we looking at the dH over dW equals, or are we looking at 3 over 2K?
These they're the same thing. This is the same thing as this. It's just simplified.
Okay, so let's see. Okay, well, if it gets bigger, it will be felt more strongly.
If this is bigger, this is bigger. Yes. Okay. So that's what we say, that if the weight is bigger, then the change in the perceived weight for every change in the actual weight will also be big, which means that it will feel stronger than it actually is. Like the pound will feel heavier. That's where this comes from. It's kind of cool. I mean, these are physical concepts that, again, like math is like explaining with equations, and that's the part where they try to, like, you know, you learn all this math, and you're like, why the fuck am I learning this? I don't care. But it ties into the real world, is what it does. And you can see it with equations like this. What's up, Grim? Grim, is your mic okay, dog? You're like super loud and like choppy. Are you okay, Grim? Grim, are you sick? You sound sick as fuck, dude.
Yes.
Oh, I'm sorry, dude. What happened? You get COVID?
Nah, it's probably because like when I was in AP US history like last week.
Yeah.
I went downstairs to the gym restroom. It's all the way outside, but it was raining.
Okay.
And I was in the cover part trying to open the door, trying to get someone to open the door. One of the teachers didn't want to let me in, so I had.
Why did the teacher want to let you in? Sorry, why did the teacher not want to let you in?
I don't know, but then like I had to run in the rain back and forth until I found someone that let me in to take a shit.
Oh, okay.
But I'm pretty sure that's why.
Oh, I'm sorry then. Yeah, yeah. My mom would always say that. Yeah, if you go out in the rain, you're gonna catch a cold. I wonder what like the biology behind that is.
And I'm still smoking. That's sad.
Yeah, yeah. Don't. Yeah, I was telling people earlier, like, yeah, stop smoking those like puff bar things you guys smoke. Like, you wonder
Stop
why you
smoking
guys
while
get
you're
sick.
Stop
Okay,
smoking
good.
while you're sick.
Well, just don't smoke in general. But yeah, I mean, this is what happens. You get sick if you smoke, man. It doesn't help. It doesn't help you. Yeah, it's a good question, Teacup. Sorry, good question,
Congrats,
Teacup. We'll go-
Teacup.
Congrats, Teacup. Yeah, we'll. Oh, well, I gotta talk to Teacup afterwards for the tournament you guys are running.
Oh, can I join? I want to see. Can it?
Yes. Let me see. Who else? Oh, I think Jamarcus had a question. Jamarcus, what's up? What was your question, dude? Was it this one? Here, let me pull it in real quick. I think I have like respiratory issues too, honestly. What's up, Ethan?
No.
I want to ask you something.
What do you want to ask me, dude?
Have you ever heard of a game called I'm on Observation Duty?
No. Sounds cool. You want to send me a link to it?
Well, it's kind of like a game where you have to memorize. It's like a spot the difference kind of game.
Oh, I like that. Like pattern recognition stuff. That's cool.
Yeah, and it's really kind of fun, but also scary.
Send me the link to it, dude. I'll check it out. I think that'd be cool.
Okay. Also, I did post a question for myself.
Okay, good. I'll go through that too. Let me help Jamarcus real quick. And then we gotta help Noise for his physics test too. OML, I'm so dumb. Wait. Oh wait, you already know this? Do you already know the answer to this one, Jamarcus? It's 40? Okay. How many positive inner solutions pairs are there for the equation x minus y, 4y equals 160? You think it is? Actually, I don't know how to do this one. So let's see. What's this? X minus... Oh, it's supposed to be plus. Yeah, because I think if it was minus, there would be infinite number of solutions to this, right? Yeah, exactly. Yeah, okay, cool. Kai? It's kind of cool. Is it 40 or is it 39? This is where I always get the... Okay, so it said positive integer solutions, right? So we're not allowed to use 0. So actually, I don't know if it's 40, right? Because if y is equal to 40, then x would be equal to 0. So that wouldn't count, right? That's all this off by 0 stuff is what it is. Yeah. Yeah, exactly, right, yeah. Because you could have 0 plus 4 times 40 is equal to 160, right? And then this would be 160. But then this is not allowed. Yeah, I think so. And then, yeah, you can't also have y equal to 0. But you could have y equal to 1, right? If y equals to 1, then x is equal to, what, 156? If y is equal to 2, then it's 152, so on and so forth. And then I think the last one you can go up to is 39. And then this is going to be equal to 4. So, okay, wait. Let me make sure that's the right number of things. I think you're still right though that it's wait. So it's 1 to 39. Yeah, so that's just 39 solutions, 39 pairs. I think that's correct. A cool question. All right. Yeah, how often do you have your Russian questions, Jamarcus? How often do you have those? How often do you go to Russian school? Once a week? And when is it? It's on the weekends? Every Monday. Okay, so you had it today. That's cool. Oh, what was up with that one question that we were trying to solve, right? The 60 to the 6? Was that right? Like, what was their answer? What did they think it was? Oh, you're gonna have it in 2 hours. Oh, you haven't had the class yet. Oh, okay. Yeah, ask him about that 60 to the 6 one. I'm pretty sure we're right with that one. Ethan, where did you get this question from?
Why you ask?
Because it's complicated. Where'd you get it from?
I just randomly search up something. I just randomly search up like physics questions, problem solving.
Okay.
And I just hit random stuff and I found this.
Oh my god.
You don't want to do this?
Well, because it's more engineering is what it is. I mean, I can do it, but
Yeah,
it's not that I can't do it. It's just I don't
know.
know. I don't know how much you're gonna learn from it. Is the problem? Yeah, it's complicated.
The thing is that this is like a mechanics type question and statistics or something.
Yes, I agree. It's a mechanics question. Yeah, right. Yeah. Even Noise is like, oh dear. I'm like, yeah, dude, what? The rod and the lamina, dude. When I start seeing this, yeah, I'm like, nope. This is engineering stuff. A smooth rod of mass m, length 2a, freely hinged to the ground at the point A, between two smooth vertical walls. No, I just want to see. I'm just curious. And a uniform circular lamina. Dude, what? Yeah. What is that? Okay. All right. Here, let's do something easier for you. Uniform circular lamina. Yeah, what is that, dude? What? I don't even know what that is. Sorry, what? Let me figure that out. What? Like this? Dude, I don't know what this is, dude. Excuse me? Yeah, okay. Nope, not gonna do it. If anyone's an engineering expert and wants to do it, they can do it for me. It's just, Ethan, sometimes things just get into buzzwords that, like, you know, if you're not in the class, you're not gonna get it. Let me think of a different question for you. Okay. Okay. Let's say... Yeah, what have you done so far in physics, Ethan? What are you doing right now?
Well, I have a test tomorrow.
What's your test over? Oh, the units conversions?
Yeah, there was that, and there was index
Okay.
notation.
Index notation.
You remember like meters per second, right?
Yes.
Write that down. Write that down. Do it somewhere.
You want me to just write meters per second somewhere?
No, not that word meters per second. Like the short word, like that.
Yeah, this. Okay. What's up?
Yes.
What are we
It's
gonna do?
like you see where that slash is?
Yes.
This is saying s to the -1, no?
Yes, it's the same thing as ms -1. That's that. Oh, that's what they call index notation?
Yeah.
Oh, interesting. Here. Let's try and do some dimensional analysis. I like these.
But that's way too easy.
Okay, well, I'm going to make this harder for you. Okay. I'm going to say, how many nanoseconds, or here, let's just do it this way. How many nanometers are in, let's say, 13 centimeters? It's a good question for you to be able to do.
Alright.
Okay. Do you know how to do this?
Yeah.
Alright, how do you do it?
No. I don't know how to do it.
You don't?
No.
Oh, okay. Well then, I mean, we did it with you, Ethan. I did it with you here, right? Remember us doing stuff over here? Yeah.
Yes.
Okay. It's the same thing. All right. I'm always gonna start off
So it's like
with question mark what? What am I looking for?
You're looking for what is nano. So it's like
Nanometers,
10
good.
to the -9, right?
Good. Yeah. Yeah, you see how we have a conversion here, right? Nano is 10 to the -9. Okay. And then what do we have also? We have centimeters, right?
Yes.
That's right here. That's 10 to the what?
Be -1. -1.
No, that's 10 to the -2 centimeters.
All right, that's it. That's it.
Right? Yeah. Deci is 10 to the -1. Good. Okay.
You know,
So- What's up?
I actually kind of say them in a different way.
That's okay.
I say it like deci instead of deci. And
You should
same goes for like. How's that go?
Yeah, what's up?
You were saying something?
Yeah, I said that's okay. I mean, you should say deci. Deci is kind of interesting.
Yeah, but it's like kind of makes it more easier than just that weird word.
Okay. All right, let's try to do this one. What do I do here with stuff?
So you gotta
So-
do like 10 to the 9, 10 to the -9, right?
Yeah, something with that. So here's what I'm going to say. I'm going to say that 1 meter, or sorry. 1 nanometer is equal to 10 to the -9 meters. Okay.
Yes.
All right. What would be the conversion thing for centimeters then? What would that be?
One. 1 centimeters is equal to. Hold on. If it's 1 centimeters is equal to 10 to the -2 meters or something.
Yes. Good. 10 to the -2 meters. Good. Okay. So we're going to now try to use these things. These are called conversion factors to convert something here. Okay. So I'm going to say how many nanometers are equal to 13 centimeters. Okay. And then what my goal here, Ethan, is to then multiply this by a bunch of different what we call like conversion factors until I get to my final answer, which is nanometers. Ooh,
Yes.
applesauce, yum. Yeah. Okay, so what am I going to do?
You do it with 10 to the -9, right? Because it's like that's what you're trying to find. Since
We're-
that's what's nanometer.
We're trying to get to nanometers, but you see how that has meters in it? We didn't start with meters, right?
Yeah. Right.
We're starting with centimeters, right? So what I need to do is I need to go from centimeters to meters, and then I need to go from meters to nanometers. It's like a 2-step process here.
Alright. So it's from centimeters to meters, right?
Mm-hmm. So how are we going to do that?
So we already know it's like 10 centimeters is equal to 1 meter, right?
Yeah, that works too. I mean, that's what this says, basically. You know, this says the same thing. 10 centimeters equal to 1 meter.
Right.
But I really don't, let's try to use these conversion factors. Okay.
You okay?
Yes. What do I do for this?
So I think you gotta multiply these two, right?
Yeah. What am I
Honestly,
gonna-
my brain's fried. You know that go. You know what happened to me?
What happened to you, dude?
My brain's fried,
Why is your brain
and
fried?
it's just Monday.
Uh-oh. It's okay. My brain is fried from the weekend.
I really wish, like, see, if it was like, on a later time, then I would be able to actually do it. But no, it's like I'm not in top shape.
Oh, you mean if the stream was later? You want the stream to be later?
No. If it was like at a different, if it was like on a Wednesday or Friday, then I would be in
Oh,
top
I
shape.
see. It's okay. It's okay. All
It
right.
was on a different day, not time.
Okay. Damn. Got you. What you always want to do here, Ethan, is these are basically fractions. Is what you want to write this as a fraction, and these are fractions that mean basically 1. So for instance, like 1 dozen, it's the same thing as like 12 eggs, right? These are two of the same things.
Alright.
So really what I'm effectively doing is just multiplying things by 1. So you
Alright.
want to use these conversion factors as fractions here to eventually go from centimeters to nanometers. Okay?
Alright. So I think you gotta multiply by -9, right?
No, not quite. So I'm going to use this one. So I'm going to say 1 centimeter on the bottom, and I'm going to say 10 to the minus 2 meters on the top.
Oh, right.
See how these are going to cancel?
Yeah, I keep forgetting.
It's okay.
And
The only way to
and
stop
you
forgetting
gotta-
is to practice.
And then you gotta do the opposite for the one, right? For the other one, right? Because it's like 1 nm over 10 to the -9 m, right?
Good, you're getting it, dude. Yes. 1 nm, right? Over 10 to the -9 m, right? See how these will cancel? Meters and meters cancel? Right?
Yes.
Centimeters and centimeters cancel. So all you're left with now, Ethan, right, is you're just left with nanometers, which that's just what I wanted. Right?
Yes.
We've successfully done it. Okay. So the last step that you have to do is you just have to multiply things on the
Solve
top.
for it.
Yeah. So I'm going to do 13 times 10 to the minus 2, which on a calculator you write that as 1e minus 2. That's what you do. And then times 1.
What? What's this E thing?
E means times 10 to the...
Oh. Okay.
0.13. And then this is divided by 10 to the minus 9, which is the same as 1e minus 9. Okay. So that gets us a really big number. Look at this number. Look, that's got way too many zeros on it. Right?
Yeah. And the teacher will want it in standard form or scientific.
Yeah, so the better way to do this, so 0.13 this is like times 10 to the 0 over 1 times 10 to the minus 9. This is the same thing as 0.13 times 10 to the 9th. Because do you remember like when we have exponents, I subtract the top one for the bottom one?
Yes.
Okay, good. So 0 minus -9 becomes plus. That's why it's to the positive 9, okay? And then if I want to convert this to standard notation or scientific notation, sorry. Do you remember like what we have to do?
Move the decimal point
Yeah, we need to move the decimal where? Where do I want to move it?
to the right.
To the right. To the right. I want to move it to the right one place, right? I want to do that. Now, if I move it to the right one place, what do I have to do with the exponent here?
Subtract it by 1 because it already moved once.
Yeah, good. Yeah. I like using
It's
this,
like-
right? Left, up,
See?
right, down, lurd.
It does go.
Yeah.
It's like, see, you're taking a cookies from the cookie jar you take when one is already gone. That's how it is.
Yes. I like that. Yeah, cookies from cookie jar. So there you go. Yes, that's your final answer, and you're done. Nice.
I think. There
Lurd mores look like turd noise. Chill. Yeah, what's up?
we go. Please wish me good luck for my physics test tomorrow.
I do. I wish you the best luck for your physics test. You're going to kill it, dude. You got it, bro.
Hopefully. Because the first one really wasn't a good result.
Oh, well, you know. Let me help you with your physics stuff. Like I'm about to help I'm about to help Noise out with some physics.
Actually, also, are we able to play games today?
Yeah, we'll play games
Or
today.
is,
No, we'll play. Don't worry, we'll play. We're gonna play Fortnite.
please let us play. Please let us play for an hour.
I'll see if I can play for an hour. I gotta also talk with I gotta talk with not Ethan. Sorry, you're Ethan. I need to talk with Teacup to get your guys' tournament started.
Chico,
You need to talk with Teacup.
what's this tournament about?
It's just playing video games and stuff. You guys wanted a tournament, so I said you guys could do it. I'm gonna fund it. So
Or is it gonna be like the same tournaments that we have been doing, like summer camp?
yeah, kind of. Ooh, yes. Yeah.
Oh.
Okay. Let me try to help out thermal physics, dude. This stuff's gross. Oh man. flow rate of the liquid? Yo, what? What are these questions? Oh my god. Hmm. Physicsandmathstutor.com. This is really what they give you, dude? This is what they give you, man? Not safe for work. You know, it depends where your work is. Okay, let's try to do this one. Alright, it says the gas occupies a volume V. Its particles have an RMS speed of U. The gas is compressed at constant temperature to a volume of that. What is the root mean squared speed of the gas particles after the compression? This is pretty cool. So, I believe that temperature is related to the kinetic energy of particles, right? And so what we say is that, you know, temp is proportional to 1/2 mv squared. I think so. Right? Because this is like kinetic energy. I think this is literally how temperature is measured. Like, what? Temperature is a measure of the average kinetic energy. Good, yeah. So temperature is the kinetic energy. And if we remember from intro physics, right? Kinetic energy is 1/2 mv squared. Okay. All right, this is where we also have to kind of use the ideal gas law, which says that PV is equal to nRT, right? And what I like to do when we have like two different situations is I'm going to move this whole thing here over to the other side. So I can say this is PV over nRT is equal to 1, which then I can start saying, I can relate this to like two different situations, which is cool. So I can say that P1V1 over nRT1 is equal to P2V2 over nRT2. Okay. Now, a gas has a certain volume, right? And it's compressed at constant temperature. So this is going to stay the same, right? So we're going to assume first that the number of moles in each gas stays the same, so that goes away. R is a constant, goes away on both sides. Assume the temperature is the same. Okay. Yeah. Dude, that is high. 7.9%. That's pretty high for a stout. I mean, I usually just drink IPAs, which are all like 6, 7, 8, sometimes 9. Okay, so P1V1 is equal to P2V2. Uh-huh. So, if the... Wait. Oh, the gas is compressed at constant temperature. Oh. Oh, this is dumb. Is the answer just B, Noise? So I was trying to like do some cool stuff here. Because temperature is related to the velocity squared, and if the temperature is constant, then the velocity of the gas particles should also be constant. Yeah, I think this is just this. I wanted to show something cool here, where like, you know, if the volume goes down by a half, right, then that means that this must go up by 2. Yeah, it's B. Okay, wow, look at that. Okay, that's easy. Wait, Noise, which one confuses you? Can you just tell me, like, which one of these questions confuse you? I mean, there are a lot of questions here. Pick one that's, like, hard for me, you know. What is the gradient of the graph? This is kind of cool. This is another cool one. I like this one. We got some flasks. You thought the first question was hard? Okay, let's just do that one. Let me do that one for you. Okay, figure 1, figure 2 show an apparatus using an experiment to confirm the distribution, blah, 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 blah. Okay. The oven contains an ideal gas kept at a constant temperature. Atoms of the gas emerge from the oven and then pass through some sort of narrow slit in a rapidly rotating drum. The drum is in a vacuum. Explain why the drum must be in a vacuum. Because if it wasn't in a vacuum, then the particles would bump into other things, you know? There's a thing called mean free path, which is like the average amount of... So, yeah, here's what I should say, is that the drum doesn't need to be in a vacuum, but the mean free path of the particle needs to be much bigger than the distance from the oven to the detector. So mean free path is how much distance a particle can move before it hits something, on average. And mean free path, of course, depends on a lot of things. It depends on how big your particle is. It depends on how big the other particles are. It depends on the temperature and whatnot. So yeah, if you're trying to detect anything from this oven, you want it to not bump into anything before it gets to the detector. You don't even get how this thing works? Yeah, okay. Oh, okay. Here, one sec. Let me... Yeah. Wow, there's a lot of parts to this question. Okay. Okay. Ideal gases don't exist. I mean, they behave kind of ideally, I guess. So, Noise, what happens is you have a bunch of particles here in this oven, right? And they're bouncing, like, all over the place, right? Which we don't like. And then eventually some of them are going to exit from this hole right here, right? And then they're going to travel this way. Now, this drum, right, is rotating in this direction, and it has a single slit here, right? Such that... Oh, thanks, Habib. Appreciate that. What's up? What's up? What's up, Habib? Good to see you. I appreciate the sub. I'm sad. What's wrong? What's wrong, Habib? Why are you sad? So anyways, there's an opening here, and only when this opening aligns directly up with the oven will the particle be able to pass through and hit the detector, which is on the other side, I guess, inside the... Or here it is. Looks like... Wait, the detector goes from 8... Oh, this is the whole detector. Ah ha ha ha! Oh, dude, I'm sorry, man. Your grandpa passed away this morning? Yeah, that sucks. Yeah. Ugh. Yeah, that's a weird thing. I hope he passed peacefully, at least. I think it's just a natural part of life at some point. I only have one grandparent left, honestly, myself. It's something that you unfortunately deal with as you get older. But it's natural. It's all part of life. You know? I always say in order for there to be space for new things, you have to sometimes have older things leave. He was in a hospital hooked up to machines. Yeah. Sounds like... Dude, that's my worst fear. Like, is dying in a hospital. I really don't want to do that. Like, because at one point, you know... Again, it's only natural for... And my personal philosophy on this is that, like, death is not the end. Death is just another step, I guess, in the whole journey of life. So yeah. Probably didn't want to keep being hooked up to the machine, so his body was probably like, "Yo, let me just chill and go to the next part. I don't need to stay hooked up here to things." It's not comfortable, dude. I hate hospitals. I absolutely hate hospitals. Yeah. Same. Yeah. Well, maybe. Yeah. That's the good thing. Your grandpa's no longer in a hospital anymore. I know it's unfortunate he's no longer here, but it's better than being stuck in a hospital, right? Yeah. Anyways, for sure. Always just remember I always like to remember also the good times we have with people. When you focus on like death and stuff, it's you know, I know your grandpa especially probably wouldn't want you to be sad. He wants you to be happy and to remember the fun times you had with each other. So it's like grieving is a natural part of being a human. Like, don't worry, we do it. But maybe try to think about how the person would want you to be feeling, you know, now that they're gone, I guess. Yes, there you go. Don't cry because it's gone. Smile because it happened. Yes, I agree with that one. 100%. Noise. Hospital's bad. Yeah, hospital's bad for noise. Oh my god. Okay. Okay. This is kind of cool noise. Okay, because here's what happens. So once this opening has been lined up and this particle right here can enter, right? And it's going to move this way, right? It needs to be traveling as this thing continues to rotate, right? This part of the detector is going to keep moving down. All right, good to see you, Jamarcus. So it needs to be going fast enough, right? Such that by the time this thing has rotated all the way down, and let's say like B is here and A is here, you know, it needs to hit this detector before the detector is no longer in its like line of sight, like its line of fire. Does that make sense, Noise? The detector is also attached to the drum as this rotates. The time it takes for the atom to move across, right, from S to AB as the drum rotates through 45... and the drum rotates through 45 degrees. Okay, in the time taken for the atom to move from S to the detector AB, the drum rotates through 45 degrees. The atom hits the detector at point C, as shown in the figure. Yeah, that's kind of cool. Okay, so they tell us this. We do need this. I need the diameter, right, which is going to be 0.5. Okay, so that's how far it travels, right, because it had to go from here to here. That had to be 0.5. And then the rotational speed, right, is 120 revolutions per second, which this sucks. Like, I don't want revolutions per second. I want like radians. I want radians per whatever. Yeah. Okay. Show the atom is moving at a speed of 500 meters per second. Okay. Rads, right? Yeah. Okay. So, we know it travels, right? This far, this distance, it travels 0.5 meters because it has to go from one end to the other end, okay? And we know it does that in the same amount of time it takes for this thing to rotate 45 degrees, okay? So what I want to know is how many seconds is equal to 45 degrees when I know... Again, this is why stoichiometry always comes up, man. Like, this is always stoichiometry, right? I know this thing does, in 1 second, it does 120 revolutions, right? And then I know that one revolution is 360 degrees. This is like the unit conversion stuff I'm going to do. Because, right, revolutions are going to cancel with revolutions. And then degrees are going to cancel with degrees. And then I'm going to be left with the amount of time. Right? So, this is... 45 over 360, right, is 1/8. And then, so we have 1 over 8 is basically what this turns into. And then times 120, so it's 1 over 960. So the time is equal to like 1 over 960, right, which is basically a thousandth. So it's basically 0.001 seconds, okay? and I needed to travel 0.5 meters, right? So I'm just going to divide it, right? So 0.5 divided by 0.001, right? This is meters over time. 1, 2, right? So this is going to go 1, 2. So this is just going to equal 500 meters per second. Does that make sense, Noise? I thought that was kind of cool. Clever, right? Yeah, it's pretty clever. Yeah. Again, I like doing this. If you ever just say, like, question mark, what do I need? And question mark, what do I have? Like, question mark, what do I need? What do I have? You can find some fun conversions which will get you to that, you know? The most important thing is figuring out what you want. It's always the hardest thing in life. Yeah. If I had, like, you know, question mark, like, girlfriend is equal to, I don't know, like, $10, like, you'd find a way. Probably involve a lot of trading things or something. You know when that guy, like, trades, like, a paperclip to buy a house or something? Yeah. Yeah. I start with $10. How do I find a girlfriend? I don't know. Play the lottery or something. What's up, Zachariah? Come on up. What's up, Zerudo? Okay. What's up, Zach? Zerudo, how's it going, bro?
Good.
Yeah.
For me, for geometry, I'm doing line of symmetry.
You doing line of symmetry stuff?
Yeah.
Oh, nice.
We already did trigonometry, so.
Oh, okay. So you do that's kind of like almost geometry type stuff. Line of symmetry, right?
Yeah.
Yeah. That's cool. You doing well in it? You have any questions about it? Is it chill?
Yeah, pretty chill.
He says I'm pretty chill. That's dope. We love that.
Yeah, I had to do this thing for English where I had to find an effective rhetorical ad.
Effective rhetorical what?
An effective rhetoric ad that's effective.
Oh, okay. Effective rhetoric is what they probably want you to pronounce it as. Yeah.
Rhetoric.
Rhetoric. It just means like an advertisement that has words on it that work pretty well. That's the simple form of it. I don't know. I think all ads have effective rhetoric. Otherwise, they wouldn't be ads. You know, people wouldn't be spending tons of money to run ads if the rhetoric wasn't effective. You'd just be blowing cash at that point. Go watch some Super Bowl ads. Those all have effective rhetoric.
I didn't think of that one.
Yeah, right? I mean, think about it, dude. They spend millions of dollars on advertisements for the Super Bowl. They're going to make sure they're effective. You're not going to run a shitty ad at the Super Bowl. Yeah. Do you watch much football, Zerudo?
Sometimes.
Sometimes. My buddies are like super into it. They watch a lot of like, I guess they went to an Eagles game, I guess, this weekend, which it looked pretty cool. I've never been to an NFL game. I've never been to a professional game. Seems like quite the party. All right, let me see. What's this other part of this question? The speed of the atom is equal to this. The root blah 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 blah. The molar mass is this. Calculate the temperature of the gas in the oven. Okay. This one, oh, they give you the mass. Temperature of the gas in the oven. This is like something with like 3/2. I mean, okay, this is what it is, right? It's 1/2 mv squared, I think, is equal to 3/2 nkt. Is this an equation that they use for you guys, Noise? And then it's like m over n is technically the molar mass. Like if you move this over, this is now the molar mass. You think it's just kT? I remember, whatever this fraction is, it has to do with the degrees of freedom, is what it is. So if something has like 3 degrees of freedom, which it can move in like 3 dimensions, you give it like 3/2 kT. But I could be wrong. You think it's just kT? That's cool. Yeah, okay. And then you just solve for this. So, oh, wait, it should be nkt. Yeah. It was crazy. Yeah, it has to do with like they have like the this and the springy things. Okay, cool. All right, whatever you can calculate. That's not too hard. Okay, well, oh, that's way too big. Let me see. Was there anything else more hard about this? I don't think so. Okay, it says the oven is kept constant during the experiment, but the pressure in the oven decreases as atoms leave through the exit hole. Explain using kinetic theory why the pressure decreases. Oh, because there's less collisions. Should be in here. Oh, these are the equations you get to use. A-level physics data and formulae. I love when they call it formulae. Yeah, where's the thermo? There we go. No, wait. Yeah, it's 3/2 kT, right? Oh, you're saying there's no n. Oh, okay. Right, okay. But then I think m here is the molar mass, is then what it is. Yeah. They should tell you that though. This is the molar mass is what they should tell you. They don't say that. But anyways, also by kinetic theory, right? Pressure times volume is equal to 1/3 nm, right? RMS. So if the number of moles of stuff that you have is going down, then the pressure will also go down. And the reason for that is because you have less collisions. If you're trying to keep the temperature the same, right? If you're keeping the temperature the same, that means the speed of these things is the same, right? Because the speed is equal to 3/2 kT. But if there are less things, pressure is kind of defined as the amount that things bounce off of the walls. That's what creates pressure. Pressure is created like within a balloon because the air molecules are bouncing off of the walls of the balloon, and that's what creates pressure. Pressure is defined as like force over area, right? At the end of the day. So the force of something colliding into something divided by the whole area of that thing gets you a pressure. Cool. And then this is the change in pressure. That also just comes down from this, I guess. This is the kinetic theory. Yeah. So you just need to calculate what delta P is here. Based on... You hold V constant. And... Yeah, I guess... Well, there's a couple moving parts here, right? Because... During the experiment, the pressure decreases. Well, the temperature stays the same, right? So the CRMS stays the same. So it's just a linear relationship, is what it is. So as the pressure goes down, the number of moles should also go down by the same factor. Yeah. That's cool. Not too hard. Hopefully that makes more sense for your test coming up. There was someone else who just joined our Discord. I really liked this guy's like comments and stuff. Where was it? Yeah, Falconer, dude. What's up, Falconer? Yeah, dude, you're welcome, dude. Where's Falconer? Falconer was here. He says, "Hi, I'm looking for a safe and friendly help for college statistics." I mean, we're definitely friendly. I don't know if we're work safe, apparently, according to some people. My instructor is difficult to understand. I wish to do well in class, but sadly, I'm holding just above a failing grade. Any and all help would be appreciated. Worked examples I have to do. Cool. I will not like to respond to PMs. I'm not interested in paying to have... I love this when people are like, I'm not interested in paying to have homework done for me. I am here to learn. Yes. Good job. Sometimes when people join this Discord, they just send me DMs. They're like, hey, can you do this question for me? I was like, okay, do you want me to teach you how to do it, or you just want me to do it for you? Because if I just do it for you, that's not going to like help you. Let's see what his homework is. You want to see Noise? Let's see what his probability homework is. Oh, very cool. This is a discrete probability distribution. Okay. Here, let's do this. Let's help this guy with this question. Noise, you should be able to do this. It's not very difficult. Okay. Cool. So, to verify it's a valid probability distribution. Yeah, there we go. Yeah, sorry. Yeah. Okay. Yeah, you just need to show that, to verify that something is a valid probability distribution, you need the probability of something happening, which is everything, to be 100%. You need it to be 1. So, what we basically just show here is that, like, P of 40 plus P of 50 plus ... P of 90 is equal to... Oh, this is a cumulative probability distribution function. I take this back. All right. Yeah, do you see how this is the probability that X is less than X naught, right? Where this is probability... Oh, 1 sec. Yeah, that the number of bicycles sold is less than X naught. This should really... Wait a minute. Yes. This should really just... This is written wrong. This is written wrong. This should be the probability that less than X bicycles are sold. Wait. What is X? Yeah, no. This is wrong. This should be like X naught is what this should be. Yeah, they wrote this wrong. This teacher's not the best. Okay. Sure. Okay. It's valid. We just want to show that probability that X is less than or equal to 90 is equal to 1. Check. There, it's valid. Find the probability that 60 bicycles will be sold next year. Okay. So that's... Okay, this is cool. So... This is the probability that you sell less than 60, though, right? Less than or equal to 60? So is it 0.61? Because that's also including the probability of like, 20. This is the weirdest distribution function ever, dude. What? Is it this one minus this one? Yeah, this question is like, this is worded weird. Yeah, no. This isn't fuck probability. This is fuck whoever wrote this question because it's worded weird. This is okay. So at least 50 and at most 70. So that's between here. So that's going to be 0.95, right? Minus 0.2. This is like a Z table is what it's like. Yeah, this is a Z table. Have you guys ever done like Z tables and stuff? That's what this is. This is basically a Z table. So we would say like this is P of 70 minus P of 50. Which is equal to 0.95 minus 0.2. So that's going to equal to 0.75. And find the probability that more than 70 bicycles will be sold. So that's 1 minus P of 70. Which equals to 0.05. I think I think they're just asking here for P of 60, which is just 0.61. It's a very, very weird question. Again, I think it's worded wrong. me tell him we went over this on the stream. See what else you had in here though. Anything else? Standard deviation, that's cool. Ooh, see there, that's binomial. Yeah, look, here's binomial stuff. This is the z-score. Yeah. Ooh, and then we're doing interquartile range and stuff. Oh, this is cool. This is all, not too bad. It's pretty. Yeah, that's not too bad. This statistics. Is this college level stats? I don't know. I'd have to ask Falconer where it's from. He said the instructor. It is. It's a college stats class. Yeah. Yeah, it's a college level stats. No, you guys go through more advanced stuff, Noise, than we do here in the U.S. I'm pretty sure. Yeah. Okay. Yeah, no, you guys go through tougher stuff in your stuff. All right, cool. All right, thank you everyone for coming to Office Hours. Had a fun time doing questions with you guys. Yeah, it does look pretty standard. It's all good. If you just found us through Twitch or TikTok or whatnot, please join our Discord. There's our Discord link, where you can find more information on all the streams we do. You can ask your own questions. Like, let us help you out with classes. I see a lot of people finding our Discord now from TikTok. And I saw actually one person in the comments even said, hey, this guy gives out free help on Twitch. You can just ask. And I was like, yes, you can. Yes. So please, if you need help, join the Discord. That way you can find out about all the streams we do. If you want to come by to the next stream, that's going to be on Wednesday. And that's going to be an hour later at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Bye, Noise. Good luck on your test, Noise. And then there's also the schedule that has when we have the streams here. Yeah. So, come by those, get the help. Let me think. Okay, yeah. So now that we are done with office hours, the next thing I do with the students is recess. So I play video games with the kids and stuff. We have a fun time. And today's Monday, and Monday's game is Fortnite. They love Fortnite. I actually do like Fortnite too. It's one of the more stable games, like one of the more consistently stable games that doesn't crash all the time. I need to have like a bone to pick with Activision, dude, because Call of Duty keeps crashing on me and it's not cool. So yeah, I'll definitely play with the students now. So if you want to play Fortnite with us, stay in the Twitch stream, and it'll pull you over. You can also just watch if you want. I tend to be, I'll talk about whatever on that stream. This stream I have to keep things kind of education related, but if you want to ask me, what my favorite flavor of pizza is, like, it's all the flavors. I love all pizza. But we're gonna do that on actual gaming. So have a great rest of your Monday. Come by Wednesday to get more help. And if you want to come play Fortnite with us, hang out in the Twitch, or if you're on Discord, come by to the Recess channel, and we'll see you there. Cool?
Hey, Dr. Go.
All right. What's up, dude?
One thing I want to say quick.
Yeah, what's up?